Welcome. Tonight I want to take you to the largest gravitational mystery in our cosmic neighborhood. Imagine standing perfectly still, yet being pulled by something you cannot see, something with the mass of 10 million billion suns. That something is the Great Attractor, and it is quietly dragging our entire galaxy through space. Over the next few minutes, I'll show you how we found it, why it stayed hidden for so long, and what it truly is. This is a story about how astronomy learns to see what was once invisible. Let me open with the number that makes this real. 10 to the 16th solar masses. A 10 followed by 16 zeros worth of material. It is not a star or a black hole. It is a vast concentration of matter we cannot see with ordinary telescopes. Watch the animation. Those figures are galaxies, and they are being drawn toward a single point, like iron filings to a magnet. That pull is exactly why our Milky Way and its neighbors are drifting off their predicted paths. Everything in our local universe is, in a sense, falling toward this invisible giant. Here is the roadmap for our journey. First, we'll examine the anomaly itself, the strange motion of galaxies that first gave the attractor away. Then we'll confront the blind spot, the wall of dust in our own galaxy that hid it from view for decades. After that, I'll show you how X-ray and infrared astronomy finally pierced that wall. We'll then arrive at the big reveal, what the attractor actually is, not what we feared it might be. And we'll finish by asking what this means for our place in the cosmos. Let's begin where every great discovery begins, with something that doesn't add up. The universe is expanding, and that expansion should be smooth and predictable. But when astronomers measured how galaxies actually move, they found a problem. Galaxies were not obeying the simple rules of the Hubble flow. Something was adding a second hidden motion on top of the expansion, and that something is the anomaly we're about to meet. Here is the precise nature of the puzzle. The Hubble law says a galaxy's velocity away from us should be proportional to its distance, the signature of uniform cosmic expansion. But starting in the late 1970s, astronomers noticed the Milky Way and nearby galaxies moving toward the Hydra Centaurus superclusters in the southern sky. These peculiar velocities deviate significantly from what expansion alone predicts. The deviation looks small in the data but is enormous in implication, because it means a massive, unseen concentration of mass is doing the pulling. By 1986, the anomaly had a name, the Great Attractor. Now, where exactly is this thing? This is the direction of the Norma cluster, part of the Hydra Centaurus supercluster. The Great Attractor lies roughly 150 to 250 million light-years from the Milky Way, deep in the southern sky. To put that in perspective, the light we detect from this region set out before the dinosaurs appeared. And here is the twist. That region happens to sit almost exactly behind the plane of our own galaxy. That coincidence is the reason this story takes a dramatic turn. Here is the cruel trick of the universe. The Great Attractor sits behind a band of sky astronomers called the Zone of Avoidance, the part of space where our own Milky Way's dust and starlight blind us. It is like trying to read a sign while standing in front of a searchlight. For years, that zone kept the attractor hidden and the mystery unsolved. Watch the animation. That's the dust, the noise, slowly clearing to reveal the bright structure behind it. In a moment, we'll see how astronomers actually did that. The Zone of Avoidance is not a physical wall, it is an observational one. It is the dense band of interstellar dust, gas, and the glare of billions of stars along our galaxy's plane. Visible light simply cannot get through, so telescopes pointed at the attractor saw almost nothing. This is why the attractor stayed invisible for so long despite being so massive. The lesson matters. What we cannot see is not always far away. Sometimes it is hidden right behind us. To solve it, astronomers had to stop looking with visible light. Compare the two columns. In visible light, the region behind our galactic plane, a wall of noise, dust and starlight that block the view completely. But X-rays and infrared pass straight through the dust as if it weren't there. When astronomers turned these instruments on the Zone of Avoidance, thousands of previously uncatalogued galaxies appeared, tracing the contours of the hidden structure. The aggregate light of those galaxies revealed enormous masses far exceeding any known cluster. We didn't need to move the dust. we needed the right wavelength. This is the decade-by-decade unmasking. In 1978, the first signs of strange, coherent galaxy motions were observed. By 1986, a team had connected those motions to a single massive attractor toward Hydra Centaurus. The breakthrough came with X-ray astronomy, which produced the first accurate maps of the obscured region. Later, infrared surveys let astronomers count and measure the individual galaxies hidden there. Finally, the Laniakea supercluster map showed the full picture. The Great Attractor is the gravitational heart of our own home supercluster. Now for the reveal. The name Great Attractor makes it sound like a monster, a black hole, a single colossal object. Watch the animation. The visible tip above the waterline is what we first saw, and the vast mass below is what actually exists. The Great Attractor is not an object at all. It is a sprawling concentration of matter, an ensemble of galaxy clusters bound together in a shared gravitational basin. It is a place, not a thing. Let's be precise about what this is. The Great Attractor is not a single galaxy, not a cluster, and certainly not a compact object like a black hole. It is a broad concentration of matter spanning the Norma Hydra Centaurus region, a genuine minimum in the local gravitational potential field. Think of it as a basin in the cosmic landscape where thousands of galaxies pool together. And here is the humbling part. This basin sits at the center of Laniakea, the supercluster that contains our own Milky Way. We are not observing some distant stranger. We are looking at our own neighborhood's anchor. So here is what the Great Attractor really taught us. For years, astronomers assumed our galaxy drifted smoothly with the expanding universe, until the motions refused to add up, and every galaxy around us seemed to stream toward a single hidden point. The dusty plain of our own Milky Way had been hiding it from us all along, and only when X-ray and infrared astronomy tore that curtain aside did we understand. This is no monster and no single object, but an immense, still-growing concentration of matter whose gravity organizes hundreds of thousands of galaxies. That is the real lesson. The forces that shape our cosmic address are mostly invisible, and each new instrument shows us just how much we have yet to see. So let's not look away from what we cannot yet explain. Keep looking, because the next discovery isn't somewhere far off. It is already pulling on us.